Sugars are, as I said yesterday, this basic biological fact. Sugars are the single most important nutrient to the entire biological world. If you don't have sugars, you die. You can have all the other nutrients available to you. If you don't have sugars in your cells, you die. They're the single foremost important nutrient out there. And for 120 million years, we were seeking out the sweetest things in the forest. And the forest was evolving at that same time to give us the sweetest things, to make us come to it, to spread its seeds. It's co-evolution. And so we have a one-to-one, we are wired with a one-to-one relationship with I need sugars to fuel my cells and I'm looking for sweet things to eat. And we know this is evident in all of us. Nobody has a curry tooth or a lasagna tooth, you have a sweet tooth. Your instincts are driving you. This isn't weak-willed, this isn't weakness, this isn't indulgence, this is instinct. And so at what point did eating sugars go from being the most essential biological need to being the biggest national killer in terms of diabetes and obesity, weight gain? It's all completely backwards. And the way that that has happened is that the sugars that are coming to us are no longer sugars in their natural form. They are sugars that have been extracted from their natural form, so they are out of context. And this changes everything. Context is everything with biology. It's not about how much of a given molecule is in a food. It's not about how much of a given atom is in particular molecules. It's about the context. Your body works on only one level of extraction of food. It has to bring things from, it has to work with things at the biological level. You can't work with individual atoms. So picking up iron, for example, you can't just suck on a nail and pick up iron. You could put that nail under your tomato plant and the tomato plant would leach the iron atoms out of the nail, bring them up into huge organic structures, and then you would eat the organic structures by eating the tomato. Your body works on that level. It doesn't mine minerals, it consumes biochemistry. And it's the same thing with sugars. If you take sugars out of their natural context, they lose their viability. Can't utilise them so well. The bad bacteria in your bowel will explode on them, it loves you for it. And then that's what squeezes out the good bacteria in the bowel, which is why refined sugar is the third biggest killer of lactobacteria. But in terms of actually assimilating these things and keeping everything in balance, refined sugars don't work for you. Your blood has to have more than that much sugar in it to keep you alive. If your blood sugar levels drop below that, then you have a store of sugars in the liver, about 12-24 hours worth of sugars to tide you over that, to keep you alive. If you do drop below that, you'll start to get numbness in the extremities where the blood won't be delivering sufficient sugars and therefore sufficient energy and life to the final delivery points in your venous network. You'll get fogginess in the brain, you'll get loss of vision, you get classic hypoglycemic symptoms, and your liver is protecting you against that for as long as it can. If you have more than that much sugar in the blood, then the blood starts to act as if it's thick. It won't go into the tiny capillaries in your fingertips and in the brain and in the back of the eye and in certain nerve networks. So you start to get numbness and loss of vision again, you get those same symptoms. Your pancreas can produce an enzyme called insulin, which will force those sugars out of the blood plasma into cells and thereby lowering the blood sugar level. But if the cells aren't calling for those sugars, then they process them and chuck them back out into the blood as hard fats. You get into fat in the blood stories, which we'll come to tomorrow. Or, if there's excess sugar in the blood, then the kidneys can strip it out. The kidneys, as I said yesterday, aren't a detoxification organ, they're a balance organ. Anything that's in excess in the blood, you'll find in the urine. Anything that's in excess in the blood in any given moment. So if the hypothalamus at the back of your brain says there's too much water in the blood, it tells your kidneys to filter out more water, and so all the water goes out, or that amount of water goes out into the urine. along with any sugars that are in excess, any proteins that are in excess, any immunological information that's in excess, anything. It's all balanced by the kidneys. And so between your kidneys and your pancreas, you never go over the amount of blood sugar in your system. And this system is honed and tweaked over hundreds of millions of years to work with whole cells, meaning that when you eat foods, it looks like that. And all the sugars and all the other nutrients are on the inside of these cells, doing what they need to do for the cells. Now you chew a few of those open, and some of those sugars come out, and you taste them when you're chewing them. It tells you that that's a sweet meal. It tells your body that that's fruit, actually. And your body then aligns itself to assimilate what it has found in these cells. And so you'll get an initial little hit of sugars off of that meal, the sugars that you broke open in the cells that you chewed up. And then as the rest of the cells digest, they will give you a trickle off of sugars, which means that your kidneys and your pancreas will have to do that much work in order to make sure there's not too much sugar in the blood. And then your liver will kick in when there's no longer sufficient amounts of sugar coming out of the blood, coming out of the food into the blood. And that's how the system was designed. A little bit of work there, a little bit of work here, just to nudge it between these boundaries. Chances are that if you're eating fruit, you'll never get round to this stage because it takes hours for fruit to stop delivering sugars to us. And so by the time you come round to using your liver supplies, you'll have eaten another meal of fruit that will have topped up the amount of sugar in the blood. So you have this fairly constant amount of sugar in the blood without that much work to manage it. If you are suddenly starting to receive most of your sugars from refined sugar, which is what most of us associate to sugars, we don't use the word sugars, we use the word sugar, which is endemic, then you haven't got intracellular sugars. You haven't got sugars that are trapped inside cells and the cells need to be burst open through the digestive process. You've got free-floating sugars in water. You eat a donut, chew that donut, all of those sugars are suddenly made available, which means that you get a huge, great whack of sugars coming out of the digestive system, and then no more sugars to come out, because they've all come out. So you get a huge amount of work for the pancreas to do, and many of those sugars will be lost to detrimental bacteria and through the urinary system. And then the liver has to kick in to make up the shortfall. Chances are that by the time you've got round to the liver needing to kick in, you're going through sugar blues, because that is the message of your body that actually there aren't the resources in the liver to keep this up. Give me some more sugar. And so usually it's another donut, or a cup of sweet tea, or a Coke, or whatever. Massive amounts of work for the pancreas and the liver. Sorry, pancreas and the kidneys. And seemingly there's no question, there's no answer to why diabetes is escalating massively. And it follows, pretty much always, pancreatitis. Pancreatitis is the inflammation of the pancreas in order to meet this workload. So we have a huge amount of work being pressed upon the pancreas in order to manage our ridiculous sugar management systems, because we're eating sugars that are completely out of context. Doesn't matter whether you're talking about sucrose or fructose or glucose or any of them. If they're out of context, they'll cause you this sugar spike. And it's this sugar spike that wears out the glands that manage the sugars. It's not rocket science, it's bloody obvious biology. And therefore, sugars, the subject of sugar, has left the realms of biology in which it is a vital, essential, the most vital, essential compound available to any cell, and it has transposed itself into the nutritional argument that says it's a dangerous chemical which causes diabetes. Nothing's changed biologically. What has changed is the context with which sugars reach us. If you use honey, for example, honey, free-floating in water, dissolved into a cup of tea, is free-floating sugars. It causes you this massive sugar spike. If you juice fruit, then you separate out, you deliberately separate out all the pulp, which is all the parts of the cells that would have slowed down the uptake of those sugars. Separate all those out and take out free-floating sugars in water, drink those, same sugar spike. Agave syrup, yacon syrup, maple syrup, all exactly the same when you're just looking at how the sugars work. The difference between how all of those others work and refined sugar is that refined sugar provides nothing whilst giving you these problems. Honey, juice, all these other things, they provide you with something. They cause you sugar stress, but they bring in nutrients. So they're all considered to be a healthy option as opposed to refined sugar. But they're not there. That's making an absolute statement out of them. In the relative world, they are better than refined sugar. None of them are better than eating the fruit you would have juiced, or getting your sugar sources from cells, so fruits and vegetables generally. It's all relative. It's always, always, always relative.
You said putting them in water. I'm presuming even if you don't put them in water, it's the same situation.
Yeah, what I mean is once you put them into your mouth and start chewing them up and put them into the digestive system, they're going to be free-floating in water, so they'll come straight through the receptors in the bowel. There's no resistance to their uptake, that's the thing. We have to remember that the bowel is designed to work with the resistance of cell structures. Anything that you do that takes that resistance away, so cooking which destroys cell structures, or refining in any way which removes the fibre, or juicing, you lose that fibrous context. And so the answer where juicing is concerned, juicing is a fantastic thing to do, because, or if you're juicing vegetable matter, because you can eat 3 meals a day and juice 30 carrots. You can't eat 3 meals a day and eat 30 carrots. So you can theoretically massively increase the amount of nutrient flow coming into the system through juice. But replacing meals with juice doesn't really work, because all you're really doing is losing fibre. So adding in juice in between meals is one way of increasing the nutrient quality. But to juice vegetables rather than fruit. Eat fruit, it's lovely. Juice vegetables, they're the ones that we've had a difficult